All right. Good morning, good afternoon, good evening, good middle of the night. Let's start and make sure you are logged into Clever. All right. I would like for you guys to just take a moment and turn your attention inward and check where you're at. Make sure that your stress level is at an okay place so that you can be and give your best in this lesson. So this is live lesson 18. We are talking about the subatomic particles and how they are different between different atoms. This is the end of week 9. Holy cow. Great work so far, you all. Super proud of you. Let's do it. All right, a couple of reminders. So I have been on a grading frenzy, including grading your short answers from the Unit 1 assessment. Please go check those, check the rubric, check how you did, see what it says, and always just check your assignments and your grades so that you can make sure that you're in understanding of what's going on, that you're fixing anything that needs to be updated, that, oh, I actually turned this in and I didn't do it. So just make sure that you're paying attention to that. With the ed puzzles, it is so important that you watch it all the way to the end. And please don't just turn in an ed puzzle if you haven't done it, or don't just turn in an ed puzzle for a recorded lesson like this one if you weren't in the live lesson and you don't watch the recorded lesson. Duh. Make sure that you guys are really trying to get into the live classes. That's the time where I can really truly teach you. And if you're struggling in this digital environment, the thing that's the most like what it would be like in school is coming to those live classes. Okay. Um, remember that we are always going to be safe, responsible, respectful, prepared, and here. And that we are appreciative of all of the work that we're doing. I'm so glad you're here. I'm so glad you're spending the time to learn something and to improve yourself every day. So today we're really going to be focusing on the last I will. I will use information from the periodic table to calculate protons, electrons, and neutrons. At the end of the day, there will be 2 new assignments that are posted for you. Do not do 40 and 41 until you have watched this recorded session, okay? Remember, we are covering periodicity this unit, so we're looking at all the elements that make up matter. So let's start with this. What are the charge of electrons? Great. So electrons, as you can see, as is hinted in the symbol here, electrons are negatively charged. Protons are positively charged. Neutrons have 0 charge. They are neutral. All right, next. Where are the protons and neutrons found? So you can see that they are found in the nucleus. The electrons are outside in the shells. You also might hear them called orbits, orbitals, clouds, regions, something like that. What is the charge of the nucleus? So looking at the nucleus that has its protons and neutrons, what do you think its charge is? Great, so it is positive because the protons have a positive charge, the neutrons have no charge. So there's a positive charge in that nucleus. Now, what is the charge of the whole atom if there are 2 protons, 2 neutrons, and 2 electrons? So it is neutral. Why? Because the positive charge of the protons are balanced out with the negative charge of the electrons. You got a really nice visual of that from doing the Colorado PhET Build an Atom. All right, so we're continuing to talk about the atom, but today we're really going to talk about protons, electrons, and neutrons and how you can figure out how many there are of each of those just by using the periodic table. So remember our structure of the atom. We've looked at this a lot. And remember our periodic table. So you might notice that the periodic table has some columns and rows. There's all kinds of information on here. Some of it we'll use, some of it we won't. The key things that we will talk about are the atomic number, which is usually in the top left corner or the middle on the top, the symbol, which is in the middle, 1 or 2 letters, the first letter always being capitalized, the second letter is never capitalized, the name below that, the full name, and then the atomic mass, remembering that that is the average, so it's going to have a decimal. We're going to have to do something with it today. So all of that information again, the atomic number, the element symbol, the element name, and the atomic mass. All are important, but for what we're talking about today, the atomic number and the atomic mass are the ones that you need to be able to quickly find in the periodic table. So if you want, I'll share with you right now a document that you can open up and fill in and then do some scratch work of calculating the protons, electrons, and neutrons, or you can do it on your own piece of paper. doesn't really matter to me, but you are going to want to have an image, a screenshot, something of this right here. This is the big stuff. Okay, so when we can figure out how many protons, electrons, and neutrons there are, all we need is this information right here. So as we've discussed, the atomic number of every element is different from each other. And that's because the atomic number represents the protons. The protons tell you what element it's going to be. So to discover what the protons are, all you need to do is look at what the atomic number is. So in this case here for carbon, the protons is 6 because the atomic number is 6. Now, the electrons are also really easy to figure out because they're just going to be the same as the amount of protons. So if there are 6 protons, there are also going to be 6 electrons. Now, to calculate the neutrons, you have to do a little bit of finagling with the atomic mass. So the atomic mass is always going to have a decimal behind it, so we need to round it, all right? And so if you remember your rounding rules from math, if it is above 0.5 and above, you're going to round it up to the next whole number. If it is 0.4 and below, you are going to stay at that number. So 12.011, that is 0.4 and below, so it is just going to stay at 12, okay? So we're going to take that rounded mass, 12, minus our protons, 6. That tells you the neutrons. So the number of neutrons in this example are 6, all right? Let's try another example together. So if we use oxygen with an atomic number of 8 and an atomic mass of 15.599, the atomic number is 8, simple enough. The atomic mass is 15.999 or 15.599. I don't know why that's different, but it doesn't matter. They both are going to round up to 16. The protons are going to be the atomic number. So if the atomic number is 8, that means the protons are also 8. Good news, also really easy to figure out the electrons because the electrons are the same as the protons. So if the protons are 8, the electrons are 8. Now to figure out the neutrons, we have to take that rounded atomic mass, 16, and subtract the number of protons, 8. 16 minus 8 is 8. If you need to throw that in a calculator, totally fine. No judgment on my end. All right? So now we're going to try 3 examples on our own. All right, so here's your first one. Great. So let's check your answers. 17 is the atomic number. 17 is the atomic number. The mass is 35.453, which if you round that is going to be 35 because it is 0.4 and below. The protons are going to be 17. The electrons are going to be 17. And the neutrons will be 35 minus 17, which are 18. All right, let's try this example. Great. So the atomic number, top left corner, 19. Atomic mass, down here at the bottom, 39.098. So again, it's going to 0.4 and below, stay the same. So the atomic mass is 39. The protons are going to be 19. The electrons are going to be the atomic number of protons. They're all the same, also 19. The neutrons then are going to be 39, that rounded atomic mass, minus 19 for 20. All right, here is your last one. So the atomic number up here, nice and big, 27. The atomic mass, 58.9. So we're going to round that up to 59. The protons are the atomic number, so 27. The electrons are the protons, the same amount, so that's also going to be 27. And the neutrons are going to be 59 minus 27, which I believe is going to be about 32, I think. Great. All right, so you're going to get lots of practice with this because your other assignments this week are going to have you doing a Kahoot where you're going to get lots of practice using the periodic table, using doing these calculations, finding the atomic number, atomic mass to figure out the proton, electron, neutron, all of that good stuff. And then you're going to finish out after you've completed all of your other assignments first and watch this video and last lessons if you have not, then you'll do the check for understanding quiz, okay? So your exit slip to wrap things up. This is kind of working backwards, but I want to see if you can figure this out. you're going to need to use the periodic table to figure out what atom might this be based on the number of protons, electrons, and neutrons. Now, my hint to you is protons are the important one because the number of protons is an atomic number. And once you figure that out, you'll be able to figure out what element this is representing. All right, so you notice that there are 1, 2, 3, 4, 5 protons. If you look at your periodic table, you find the atomic numbers at the top, 1, 2, 3, 4, 5. Element number 5 is an element named boron. Cool. All right, so we are going to come back to this, and you're going to get lots of practice with this next week. Don't worry. Spend some time working through the Kahoot and see how you do. Other than that, have a great weekend. I will see you guys next week. Thanks for your time and effort.